So the basic ground rules is please be active and attentive, right? Be on mute when the session is going on so that everyone can make the best use of the time. Questions will be taken, of course, at the logical end of every step. So whenever we are done with a particular topic, I'll basically quickly look at the chat window and quickly answer questions. Also, you can ask questions and so on. But primarily try to ask in text chat so that I can answer more of them, right? Raise your hand or drop a message in the chat box before the question is asked, and respect others' time. Okay, do not really hijack the discussion. Do not monopolize in that senses. Okay, it's basically just so as to have a good learning experience for everyone. Okay, so that's that. Yeah. So a little bit about me. So effectively, so my name is Manish Gupta. You might have, heard about me from other places. My educational background is like I finished my PhD in 2013, and masters from IIT Bombay 2007, BTech from Mumbai University 2005. And currently I work as a principal applied scientist at Microsoft. And also, when I get time, I also work as a visiting faculty at ISB Hyderabad and adjunct faculty at IIIT Hyderabad. Okay. So that's a little brief about me. So let's basically straight off get into the discussion of what is data science and various aspects of data science from that perspective. And finally, a little bit of healthcare use cases that we'll talk about at the end. Okay. Okay. So, what is data science effectively? Now, this is the biggest question that one needs to know. And there is so much of ambiguity around this topic that it has become very fuzzy. What is data science? Right? Data science is science about data, as the word itself says. It's about asking the right questions and analyzing the raw data, right? So science is about a very systematic method to understand things, right? And data science is about doing the same thing, but in terms of data. So it's just about given some kind of data, and data could be anything. I mean, it could be like Excel kind of structured data, or it could be chat logs, or it could be documents on the web, or it could be some graph kind of data. It could be images, it could be videos, it could be of various forms, right? It could be tweets and so on. It's about asking the right questions and analyzing the raw data, modeling the data using various complex and efficient algorithms. So of course, over this course we'll learn about multiple algorithms. How do you model it? In fact, some of them are mentioned around that circle that you see. So effectively, applying some statistical algorithms, pattern recognition algorithms, data mining algorithms, machine learning algorithms, AI algorithms, neural networks, and so on. So using a combination of these various algorithms, and then model it. So model the data so as to understand it better, right? So as to monetize and exploit it better. Okay. Then visualize the data to get better perspective. So many times modeling has to be done, but before modeling, you must explore the data enough. So it's also technically called as exploratory data analysis, or EDA. And a part of exploratory data analysis is also visualizing it well, so as to understand the hidden patterns or the explicit patterns as they may be, right? And gather that from data. Okay. So, and lastly, understanding the data to make better decisions and finding a final result, right? So, data science is all about using the raw data that is collected within the organization as well as externally, so as to make the best use of it in terms of finding insights which are actionable in a business sense. Okay? They're actionable insights which lead to profits for the business finally. Okay? So that is basically what is data science all about. Okay? So what is the, where is the need for data science? Okay. Now, if you think of it, in the past few years, like couple of years, people have started investing a lot in data science. Why? Okay. And not just IT companies, believe believe me, these are not just IT companies, these are companies all across sectors. If you still think of it, hey, I will discuss various use cases in healthcare today. Healthcare, agriculture, education, you name it, various sectors are interested in data science. Why? Okay. They're interested because people have started realizing that if you use data science, if you can understand your data better, you can actually come up with really good competitive insights which make your business perform more effective and more efficiently compared to others. other competitors. Okay. So this revolution of technology, it's a revolution of technology, right? I mean, if you ask me 10 years, 15 years back, what was the revolution? Well, it was Hadoop or big data kind of things. Now it is data science, okay? Or more so, even further down the line, it's deep learning. Maybe at some point it'll be quantum computing, things of those kinds. It's like a wave that has come up, okay? So, it has come up because of multiple reasons. First primary reason is there is availability of large amounts of data now. People have gone online. Many things happen online these days, right? Second, there is a whole bunch of compute power available, compute power, storage available, cloud, cloud things available. So things have come online, right? And there's a whole bunch of compute power available. And third, there is a good enough amount of algorithms available, optimized algorithms which have enabled the awesome use and awesome exploration of this data. Okay. Now, if you look at roles across industry, in this particular field of data science, many companies have already established roles of data science. Now, and these roles typically fall into these three buckets: data scientist, data analyst, and a machine learning engineer. Okay, so these roles differ a little bit. Now, of course, these terms are very abused in the sense that many companies just call everyone as data scientist. Okay, now sometimes even people who essentially just know how to use Excel are called as data scientists. Okay. But on the other hand, a little higher level of people would be people who know not just Excel, but also some good visualization and reporting tools. Okay. So for example, they know Tableau or Power BI kind of things. Okay. Now, even further, if you look at it, there'll be people who know ETL tools. So extract, transform, load tools like like data stage or Informatica or SIS, so SQL Server, Information Services, and so on. So those kinds of things, right? And even better kind of data science roles are the ones who are real data scientists, in the sense that they basically know how to do machine learning really, or predictive analytics, or building recommendation systems, things of that kind. Okay. So primarily there are these three kinds of roles: data analyst, data scientist, and machine learning engineer roles, and by the way, these are like insane opportunities. So whether you take startups or you take established companies, there are insane opportunities for these kinds of roles. Okay. So typically these roles are paid much higher compared to normal software engineer roles. Okay. So that's another thing why you should really be excited about this field of data science. I mean, I have been in this field since I started my master's in some senses, so like 2005. So for me, it was like a natural progression to see how this field has grown. But now that this field has grown, it has actually started being very important from an industry perspective. Okay. So who can learn data science? I mean, if many times people have these questions, and again, there are people of various backgrounds. Some guys are actually very freshers whom I have interacted with. Some guys are like VPs of already established companies, but they are not into data science. They now want to move into data science. So people of all kinds of ages and all kinds of background, educational background or experience background, can learn data science honestly. I mean, at ISB, I have had people who have like 10 and 15 and 20 years of experience who are now actually getting into data science. Okay. In fact, at IIIT, I had a PhD student who actually was like 10 years older than me, honestly, and she finished off her PhD even with kids, with much older kids, right? So that's the idea. So any graduate student, even people from non-IT background, clearly, right? So I have had people from banking background who actually could grasp the data science concepts and make it to data science jobs. Okay. No prior coding skills. Yes, to these days, a whole bunch of machine learning is automated machine learning, right? As in some of those sessions, I'll also talk about automated ML, in the sense I'll show you drag drop kind of things. So even if you don't have any prior coding skills, many times you don't need much of coding skills. But that said, of course, a whole bunch of things can be done if you know some coding. And of course, we will cover that in the Python course. Right? Exceptional curiosity. That is the most important thing. Okay. The last bucket is the most important. You must be curious about data. Science cannot happen without curiosity in some senses. And therefore, the takeaway thing that you need to have if you want to learn data science is curiosity. Okay. And the eagerness to learn it. If you don't have that, then surely nothing can help you. Okay. But if you have that, that is practically the only thing that you need, honestly. Okay. So that's that. Okay. So, there are various components of data science. So data science is not just a topic by itself. It's basically an amalgamation of multiple such subfields. At the core of any field in computer science, data science is more of if I can think of mainly derived from computer science. But any core of computer science is actually mathematics, right? So it all starts from maths. That's the base, right? On top of that, there is statistics. There is the whole of computer science. But again, we don't care about the whole of computer science. As data scientists, we really care about that part of computer science which is purely applied in nature. Okay. So, for example, we'll not talk about operating systems or or compilers and so on, but we'll be interested in that. Machine learning aspect of computer science. Okay, so machine learning, data processing, domain expertise, all of these, this domain expertise is something which is a little different from other fields that comprise data science. Right? So other fields are maths, computer science, machine learning, stats, and data processing, and so on. But this domain expertise is very important, as I will also talk about in the healthcare use cases at the end. It's super important if you are working in a specific domain where you're applying data science. Okay, so many times data scientists have this ego that, hey, I'm a data scientist, I know everything. But it's always good to sort of keep that ego down when you're talking to a domain expert. For example, if you're doing healthcare data science, you should always respect the healthcare doctor guy, because after all, they are the ones who can help your data science solutions become really good. Okay, so that's an important bucket to remember. Okay. Of course, it also involves visualization aspects. So, how do you visualize your data and how you can tell the stories based on those visualizations nicely. We will get back to it, in a couple of minutes. Let me quickly just talk about the last few remaining things, and then we'll get back to questions again. Okay. Okay. So, just like any typical software development lifecycle, there is also this data science lifecycle, and the model is pretty similar to a typical SDLC, software development lifecycle, right? So first step is to actually gather the business. So have a business understanding. So, a business analyst typically goes, discusses the details of the machine learning data science project and gathers requirements from the customer, right? Second step is data mining or exploring the data. Hey, we have discussed the project, but we do need data to finish off the project. So can we discuss the project? Data cleaning. This is typical, typical data. So data cleaning also involves data integration. Doing a whole bunch of things around integrating data and so on. Oh, is this? I see. So is the screen visible? Everything good? Oh, I see. Voice is not audible. Is my voice audible? Can someone sort of?
Yes, Manish, we are able to hear you.
All is good. All is good. Thank you so much. Yes. Thank you so much. Yes. Okay. So yeah. So essentially, data cleaning. This also involves data integration, especially if you have data coming in from multiple systems and so on. Data exploration, EDA, as I talked about. You try to figure out outliers, missing values, a whole bunch of things. Again, don't worry about too many things here, right? Because over the course, we are actually going to go over these specific things in much more detail. Okay, but it's like a broad overview of what typically a data scientist does. Okay. Then there is feature engineering. Feature engineering sort of involves coming up with important signals that could be important to finish off the project. So given this data set or some sort of data, how do you sort of extract the most important signals out of the data so as to finish off the project, right? Then predictive modeling. So coming up with models, as they call it, machine learning models, right? Coming up with evaluation, so metrics as to how good these models are, and then making predictions and so on. And finally, visualization. So, after the project is done, how do you sort of visualize the data appropriately? How do you also come up with the appropriate plots, graphs, interactive visualizations sometimes, so as to, so as to convince the stakeholders that yes, the project is done and here are actionable insights that you can leverage. Okay. Now, data science has become so popular because there's a whole bunch of data that is around, right? data in terms of, in terms of volume. So if you just look at this slide, of course, I'll not go over all the stats, but in a single minute, insane amount of things keep happening all across on the web. Lots of volume of data, lots of variety of data that gets generated, data getting generated at a large speed, right? Sometimes you're not sure whether the data that is generated is true or false. So veracity is important. Veracity meaning, credibility of the generated data. So, you have lots and lots of posts on Twitter and Facebook, but who knows what people write? They may be right, they may be wrong, fake, and so on, right? Okay. So the value and, some data points are very valuable, some of them are not. How do you sort of figure out which ones are valuable and extract information from them? Okay. Now, and again, data science actually is of multiple steps. Basic stuff is just raw data. If you process it, you get some sort of information. And typically, in traditional information theory or information science, people talked about descriptive information. Okay. And data analysts or business analysts, data analysts were folks who could just do Excel stuff and describe the basic statistics, right? But now data science has moved on to other kinds of things, diagnostics. So, figuring out if some event happened that is extractable from the data, why did it happen? So, for example, if the sales dropped in a particular region for, say, a particular supermarket, then why did it drop, right? Predictive. So, what and when it will happen? If can I sort of forecast sales, right, in the next quarter? Prescriptive. So, if I want to increase the sales in a particular store, how do I do that, right? So, all those things have become part of data science now. Now, the base of data science is artificial intelligence. Okay, so in fact, the goal of artificial intelligence is to make any machine try to imitate a task that a human can do. Okay, so you might have heard about this Turing test. Okay, so Turing test, if you have not heard, it's time to search for it. After this session, go search for Turing test. Right? It basically simply says that, hey, if I have a room in which I have put up a robot, right, and I have access to the robot only through, let's say, a small window. Okay. I ask questions to this robot and it answers those questions to me. Can can this robot behave as if, I don't understand whether I'm talking to a robot or a human? Okay. For example, I ask, what is your favorite color? It can talk as seamlessly as a human would do. Or if I ask them who is the Prime Minister of India, it can answer as seamlessly as a human would do, right? So that's the goal of AI. Okay. Now, machine learning is one way to achieve that goal. And therefore, see, machine learning is a small part of AI. Okay. And similarly, deep learning is a way of doing machine learning. So many people have this confusion, and there are so many names. How are they related, right? So, and this slide is to really help resolve that confusion. So AI is the big thing. Machine learning is a part of AI. There are many other parts, by the way, right? For example, NLP is yet another part of AI, natural language processing, computer vision, or graph mining. Those are all different parts of AI. But machine learning is the most important part of AI. Okay. And then you have deep learning, which is a part of machine learning. Now, again, there are many ways of doing machine learning. One of the ways is deep learning. And artificial neural network is a particular way of doing machine learning, which is basically deep learning. So deep learning is essentially comprised of artificial neural networks, as we'll see, when we talk in detail about deep learning at some point. Okay. Now, if you look at the broad machine learning scenario, there are, a few main buckets. So you see machine learning at the center, few main buckets called as supervised learning at the right, unsupervised learning, and reinforcement learning. Now, among these all buckets, the most important bucket is supervised learning. Okay, so most people, 95% of use cases in industry are around supervised learning. Okay, and the remaining 5% people really do unsupervised learning. Now, you might be thinking reinforcement learning kidhar gaya, right? So that's practically a very small percent of people, honestly. So only companies which are involved in, say, robotics or companies in gaming essentially care about reinforcement learning as of now. Okay. But most of the companies really care about supervised learning. So a company which says I'm doing data science must be doing some supervised learning. If they're not, then they're really not doing data science, honestly. Okay. So, when you talk about supervised learning, in fact, a whole bunch of those people do classification, and that too using decision trees. Okay. So if you ask me, 50% of the companies really, when they build a decision tree, which is basically a classification mechanism, right, which is under supervised learning, they basically say, hey, we are doing machine learning. Okay. Does that make sense? So this is the most common thing that people do. They do supervised learning. Within supervised learning, they primarily do classification. Some of them do regression. So, and again, next few slides I'll talk about that. But that's basically the broad picture of machine learning. That there is supervised learning, unsupervised learning, reinforcement learning. Remember those three buckets, right? Others, don't worry about them. We'll look at them in detail later. Now, let's think of this kind of a thing, what kind of problems you can solve using data science. So, you can solve these kinds of questions like, is this A or B? So is this email spam or not? Is this tissue cancerous or not? And that's basically called as binary classification problems. And you will do it automatically. So you'll build a model such that you basically give it this new tissue image and you ask it whether it is cancerous or not in those senses. Okay. So is this different? So, you can also ask questions like, hey, there are these 15 things, out of that, is this one thing different? That's called anomaly detection. And that's also a part of this data science thing, right? Third question is how much or how many? So, you want to basically say how much will be the stock price of Microsoft tomorrow? And that's a regression problem. How much will be the, temperature in Hyderabad tomorrow? That's a regression problem, okay? How is this organized? So if I have photos on my phone, can I organize them better, into home photos, office photos, and, Paris trip photos and so on? That's a clustering problem, grouping problem, okay? What should I do next? So basically, if I am playing this game, what is the next best action so as to optimize the final reward? So, how do I play chess so as to defeat the grandmaster out there, okay? And that's basically a reinforcement learning problem, okay? So those are some of those problems that I can talk about, which are a part of data science. Okay. More details about classification. So, again, classification, this is a simple example where I've shown some Excel looking data set at the left and some sort of a tree which is built on the right. Okay. And the idea is that, how do you construct this tree automatically is what is classification all about. There's a whole bunch of use cases I've listed at the top. So, input could be document, and, you want to say whether this document is spam or ham, in the sense, is the email spam or ham or not, and so on. Okay. So that's classification. We're also talking about clustering. So here I've shown clustering could help you figure out those clusters or groups. Okay. For example, clustering photos on your phone or clustering various objects like carpet fibers and so on in this particular picture. Clustering is also known as publicly something called as market so it's basically also known as user segmentation. Okay, so many people use clustering for user-based segmentation in that senses. So that's basically clustering. Yeah, and then there is deep learning as well. So which basically is about using neural networks to do complex things like driverless cars or face recognition on Facebook when you upload a photo and so on. Okay, so at this point, I'll just pause and see if there are any questions. So as of now, no. But folks, don't wait for me to sort of ask you to ask questions, right? I strongly motivate people to ask questions, because when you ask questions, you not just clarify your doubts, but you help others also clarify doubts. Okay, so do ask questions. Okay. So, but since there are no questions as of now, I'll keep going, for the sake of, for the sake of time. Okay. Okay. Now, data science has use cases at many places. In fact, if you ask me, I've done workshops for variety of, organizations invested in various kinds of domains. Okay. Now, lots of use cases are in healthcare. So at Microsoft, in fact, I used to work for a healthcare for almost like 3 years in machine learning in healthcare in some sense. Okay. So, then there's a whole bunch of data science applications in transport. Self-driving cars is the most, jazzy application one can think of, right? How can you have cars which drive themselves, right? No driver at all, right? So it involves a whole bunch of data science use cases. Yes, so just to give you a glimpse of self-driving cars, you need to make so many complex decisions, right? As a human, when you're driving a car, of course, there can't be a self-driving car anytime in India. Don't think about it, okay? Indian driving is way more complex, but there are self-driving cars possible in the US and developed countries. So, you need to solve interesting data science problems. Like at this point, should I steer like 5 degrees or, keep going straight? Should I increase my speed, decrease my speed? Where is the lane marker? I need to be in the same lane, especially in the developed countries. Is there a signal? Is there a signboard? Is there a pedestrian on the road? How far is the pedestrian? Is there a car in front of me? How far it is? All those complex decisions need to be made at 30 frames per second. Remember, our eyes can actually see things at 30 frames per second. So how do you do that, using data science? insane number of use cases in finance. So basically, algorithmic trading. So if you are into algorithmic trading, you would know, or in general, if you are in trading, then, predicting whether the stock will go up, down by how much, and so on. Will the index, will the stock market index go up, down, and so on. E-commerce, many applications. Amazon shows you things like, you bought this, you might also want to buy another thing. Now, those recommendations are all data science driven in some senses. Okay. Manufacturing, lots and lots of applications. So, I've worked with cement companies, I worked with construction companies, consulting them on manufacturing use cases. So, for example, very simple use case with L&T. One of the use cases that you're working on was on construction sites. There are some codes, rules that people have to follow. For example, there are hard hat areas, and workers must wear hard hats in those areas. Are there violations that you can detect automatically? Okay. So these guys have started installing cameras which continuously take pictures. They are sent to, the central hub, especially typically on the cloud, where these pictures are analyzed automatically so as to figure out violations. Okay. Or figuring out if there are delays in the project that are going to be there. Construction projects, many times they get delayed, right? Can you automatically predict those delays? Many use cases, honestly, right? Banking, finance, right? So at the end of the day, every bank, right, some guy sits down and verifies on those 1,000 checks that were deposited in the bank, whether this check, the amount in figures and amount in words match or not. Hey, you can actually do this using data science now, right? That's the idea. And so those are some use cases. Of course, there are typical popular use cases like fraud detection, figuring out the customer's lifetime value, and therefore offering them a better percent rate of interest or lower home loan interest, and so on. You're figuring out whether a loan should be given to this person or not based on credit risk. All of those are essentially data science problems. Okay. And again, this slide I've just put for reference. I'll not go into reading out everything, but these are the kind of various areas in which there are these data science applications. In fact, one time I did this workshop for Andhra Pradesh, AP government officers, and they wanted to do to explore data science use cases across all kinds of government domains like civil services, fisheries, you name it, law, and so on. And they want to bring in data science into everything, honestly. Yeah. That's the idea. Now, the most important thing is, how do you go about doing all this? This all seems fancy, but how do you do all this? And that's what these courses nicely designed so as to help you understand the flow and understand concepts in a lucid manner. I mean, step-by-step manner. That is where these courses help. Okay, data science is vast. If you just go online and try to read about it yourself, it'll take forever. You'll get lost in the sea that exists, right? And that is where these courses have come up with a nice plan and tie these things together. Whether it is here or ISB, the kind of things that I do is to sort of follow this nice thread and flow of things so that people understand these concepts in a step-by-step manner, finally reaching to a level that they can go out and work in industries. Okay. So there are various tools that you need to put into your kitty, in your toolbox, right? These include programming tools, okay, like Python, okay? And again, now in Python, there are Python is vast by itself, but there are specific libraries that are data science oriented, and you need to know them, like Pandas, NumPy, SciPy, Matplotlib for visualization. So Pandas is basically for data frames, understanding how to load data and so on. NumPy is numeric computations. Matplotlib is visualization. SciPy is scientific computations, and so on. So all of those libraries, of course, there is also these natural language processing libraries like NLTK. Those will be covered here, right? Then there'll be other kinds of things like data processing tools and analytics tools. Some of you might know already some of these, but it is important to learn Tableau, Power BI, MySQL kind of things. Okay, and then there are pure AI or data science tools, which are like machine learning oriented tools and algorithms, right? So AI algorithms, machine learning algorithms. So the right side is more of an algorithmic thing, right? So computer vision, NLP, deep learning, how do you use all of these kinds of algorithms? So given a kind of a data and a project, the basic goal is to identify which algorithm suits this project, right? Which algorithm will help you meet the business goal that has been defined for you, okay? So with that, I'll just very quickly talk about these use cases in healthcare sector that we have done, as part of Microsoft as well, so as to tell you, how data science is being used these days, okay? So LV Prasad Eye Institute is one of the popular eye institutes all across Asia. It is headquartered in Hyderabad, right? And we work with them, on this interesting use case. So a kid, many of you have specs, right? Many of you have glasses. So when you go to a typical eye doctor or an ophthalmologist or optometrist, typically people go to optometrist, right? You basically get your eyes checked. This guy basically tells you, hey, put your chin on this thing and look into focus on that dot, and the machine churns out some numbers and tells you, hey, this is your sphere, cylinder, and axis. He basically prepares glasses and gives you, hey, these are your lenses, basically wear them, right? Can I do forecasting? Not just tell you your current eye number, can I sort of tell you the eye number after 2 years? And that is what we did with these guys, okay? So, in fact, what we did at LU Prasad was to tell people that, hey, when a kid visits, we can give you these forecasting charts, tell you after 6 months, after 1 year, after 2 years, this is how your eyes are going to behave based on various eye parameters and based on your current history, right? We can tell you what will happen. In fact, we also showed these kinds of pictures to people saying that, hey, in a classroom, at some point, hopefully we'll meet in a real physical classroom. But anyway, in a classroom, we would print and give these kinds of pictures saying, hey, this is what you can see, the left bottom, this is what you can see right now. But 2 years down the line, this is how you will be able to see if you do not follow our advice and wear the specs, okay? So this data science use case was from a patient adherence perspective. See, in healthcare, patient adherence is a very big problem. People are suggested treatment, people are given eyeglasses, but they don't wear them, especially for kids, right? Kids are naughty. I mean, and especially, they don't want to wear eyeglasses because, hey, they can still see, right? And it's just that they can't see clearly. So therefore, to instill that fear in them, this particular solution is super important. So yet another thing is we did was for doing this glaucoma intraocular pressure prediction, IOP prediction, okay? Just like we have blood pressure, there's also pressure inside our eye fluid, okay? And that's basically called as IOP, intraocular pressure, okay? If that pressure, just like if our blood pressure goes bad, we get like blood pressure as a disease in some senses. If our eye pressure goes bad, that's called glaucoma, okay? And glaucoma is a serious problem for eyes. Some of you might have known that because of your relatives and so on. So glaucoma is a problem where you cannot see the entire thing. You can only see in a small zone. So, you can only see in this narrow cone rather than seeing everything. So if I want to see on that side, I can't just, squint my eyes and look like that. No, that doesn't work, okay? I have to actually rotate my head and then look like that, okay? That's a glaucoma problem, okay? Now, the idea behind this use case was, given various information about these patients, can we sort of automatically predict that, hey, given current eye pressure, and given these medicines that this guy is taking, can this, what will be the futuristic eye pressure? So that is what we want to predict. And that's super important because, of course, maintaining eye pressure is the way to contain glaucoma, to actually make sure that glaucoma doesn't spread in the remaining part of your eye, okay? Now, again, other use cases included given this eye images. So these images that you see on the right are eye images. They are also called as fundus images, okay? So given these images, automatically figuring out if this guy has some disease. So here we have, I've just named it as diabetic retinopathy, but we worked on multiple diseases, diabetic retinopathy. There are other diseases like age-related macular degeneration. And, again, we don't need to get into medical science here, but believe me, for this, actually, I learned some medical science as well while working all these healthcare use cases. You have to, because you have to know the domain so as to do data science really well, okay? But you can know domain slowly over time. It's important to first understand how these algorithms work. So how do you take an image and automatically identify if it contains an anomaly or not, right? So a particular disease or not in this particular case, okay? So there are a bunch of other use cases in healthcare that I can talk about. So we also worked with Apollo on predicting the cardiac risk for a patient in the next 5 years. So you do an executive health checkup with Apollo and go there, and Apollo can actually also tell you what is the risk that you will get a heart-related disease in the next 5 years. Okay? We work with SRL Diagnostics on trying to figure out, given an image, does it contain a particular type of cancer or not, right? So lots of such interesting use cases exist in this nice field of data science. And I just talked about a few in the healthcare side, but I mean, the healthcare is just one story. As I told you, there are so many interesting stories that we can talk about all across domains, right? Whether it is like, transportation or HR analytics or, tourism industry. One of my students actually working on an interesting tourism use case. So automatically, looking at lots of reviews and blogs and identifying the right time to visit a particular location, yeah, and doing it at scale. So, what is the right month, whether you should visit in the morning, evening, things of that kind, right? Of course, some of those things are available on TripAdvisor, but TripAdvisor has limited coverage. Can we extract those from web pages and so on? Many use cases that I can talk about. Okay, but I think yeah, I think I should wait. I should take some questions. So therefore, I'll sort of just conclude with this takeaway. We are living in a data-rich world. Okay, guys, soak this in and make sure that you really take this from the spirit of it. We are living in a data-rich world, and compute power is cheap these days, available in plenty. And therefore, businesses are getting transformed, where decision making is now switching from an experience-based decision making to being data-driven. Okay, now a 30-year experienced guy is not as important today in today's world compared to a 3-year data science experienced guy. Okay, the way to survive is really to embrace the data science revolution. Okay. And therefore, one should keep in, but however, one should keep in mind potential pitfalls, when taking up these data science solutions. One should know what is the right way to implement these solutions and so on. Okay, and which is what you learn here. Okay, which is what you learn here. Enjoying data science by putting a reasonable amount of time is the key to success. So, see, we can only guide you, and I say this to everyone, whether it is ISB, IIIT, or here, we can only teach things. Now, how much you can take really depends on how much time you put into it. Okay, it's important to have, I mean, you have already taken the first good step. You've already taken a good step by enrolling in a dedicated course, right? But to make the best use of it, I think you need to put in time. You need to sort of be serious about it and make sure that you do that you really make the best out of this opportunity. Okay. Okay, so that is all I had, and now I'm up for questions. So basically, folks, ask questions. Yeah, see, folks, when I meant you need to be, curious. You need to ask questions. Okay. So questions, guys. Yeah, looking for questions. Let me, let me see if you can. Yeah, go ahead. Someone wants to ask questions? Yeah.
Hello, sir.
Yes, please go ahead. Bibhu, yes.
Yeah, sir, can you, yes, Bibu here. Sir, can you please explain how the e-commerce domain and data science is related? Like, can you
What are the
brief me a little more?
awesome. What are the applications, right? Very good question, Bibhu. So
Yes,
e-commerce, right? Let's talk about companies like Amazon or Flipkart or ShopClues and Walmart. So many e-commerce companies, right? See, e-commerce companies have to solve at least a few of these data science problems. One, when a customer comes and searches for something, how do I show the most relevant results? Okay. So for example, you go to Amazon. Okay. So let me quickly, I think I'm sharing my entire desktop, so you should be able to see what I'm typing in. Yeah. I mean, I go to Amazon. Let's say I search for, whatever, iPhone. Okay. So then, it shows me these results. How does it sort of sort them? Of course, there are like millions of products on Amazon. How do you figure out, the best matching ones? Of course, a very simple thing to do is to just do an exact match. So iPhone hai, of course, there is an iPhone here. Good, life is good. Okay, but life is not always so good. For example, let's say if I want to search for rye. Okay, so many of you understand what is a rye. Household things, right? If I search for rye, will I get the results? Okay. I don't get, well, by the way, I do get good results. Okay. So Amazon is doing a good job now. Honestly, it was not doing a few days back. Okay. But yahan to rye match ho gaya. But many of those sellers just put mustard. So then there is a, but Amazon is able to still figure out these things, even if rye is not mentioned sometimes. Okay. If they can, if they cannot, then they must improve their algorithm. But what I'm trying to drive the point is that rye search kiya to bhi mustard aana chahiye, right? That is the thing that I want. So search is very complex. Okay, it's not a very simple thing. It's not just about matching the exact keyword. It's sometimes matching the translation, sometimes matching similar meaning words. Many times what happens, for example, if I'm searching for, let's say, Canon, or maybe I'm searching for, let's say, laser LBP 2900B printer cartridge. Okay, I'm looking for cartridge, not the printer. Okay, and now let's see what happens. Okay, so fortunately they can show cartridge at the top. Okay, but sometimes they will show printers at the top, not understanding that, hey, I am not looking for the actual printer, I'm just looking for the cartridge. Okay, so not just looking at those keywords, but also identifying which keyword is the most important. Okay, if I just looked at printer, man, I would have shown printers out here. But now I understand cartridge is the most important, and not always the last term is the most important. Okay. In fact, hopefully I can actually take cartridge and put it as the first term also, and still I'll see cartridge results at the top, right? How do I figure out that people are not looking for printers, but for cartridges actually? Okay. Search is a very important problem that they have to solve. Okay, search is after all a part of data science, and because after all it depends on some data and you have to process it in a manner so as to show nice insights to the users. Okay, another problem is recommendations. Okay, so for example, if I try to buy this, right, if I just like click on this cartridge, okay, they also show me interesting things, for example, related to this item. How do I figure out other products that are related to this item? Okay, how do I also figure out, sometimes they also show bundles, people who buy this also buy something else. Okay, so not here possibly. Yeah, but many times you have seen that that widget comes up, people who buy this also bought this. So sort of called as cross-selling in the real world, right? Cross-selling and upselling. So how do you do that? That's another data science problem. Okay. Now, Amazon is a exchange kind of a thing. People can come up, put up, product descriptions, and they sell products and so on. How do you figure out credible people? So, or how do you figure out, how do you do content moderation? So people can put up adult content also here, right? But it is your platform. You want to make it safe for people to use. So how do you do content moderation? Automatically figure out that these things that are being uploaded by these manufacturers are all reasonable. They are not unreasonable things. Okay. So, for example, especially in fact, in some countries, not just about adult content. In some countries, certain things are banned from being sold. So how do you then, make sure that this particular thing is not sold? For example, in India, you cannot sell things which have or rather, it is demotivated to sell things which have the Indian flag printed, say on shoes or things of that kind. So how do you do that moderation of content, right? How do you figure out that the images that the manufacturers uploaded are really pertinent to the product that they have basically they are selling? Okay. Those are all interesting problems. And again, I'm not even getting into other kinds of problems that Amazon has to deal with in the hardware side. For example, trucks have to basically move things from their godowns. So how do you do route optimization of those trucks and so on? So that is a different world altogether. But even on an e-commerce portal, search recommendations, those are interesting problems to solve. Okay. Okay. Does that answer your question, Bipu?
Yeah, yes. Thank you.
Yeah, great. Other questions? Yep. Okay. Guys, you can't be silent. You have to ask questions. Come on. Okay. No questions?
Hello.
So, yeah, go ahead. Yes, good. Ankit?
Sir, actually, yeah, Ankit this side.
Go ahead, Ankit. Yes.
Yes, actually, I'm little bit scared of doing coding and all these things. That's choose MBA in marketing for my years. But yeah, if when you told that there is some little bit part of coding in Python, so,
Yeah.
sir, how can I deal with these things like coding and all these things like modeling, happening AI?
Huh?
Very good thing, Ankit. So,
Because
let me tell you
somewhere
this.
yeah,
Yeah,
sir, because
go ahead.
somewhere I have to
Budaya
deal
ka?
with all these things. So that's why I'm little bit scared again.
Yeah,
Biscuit
very
and
good, very good. Thank you. I mean, I appreciate your courage, Ankit. I mean, coming out and being clear about what you are scared of. Super awesome. You've already taken a good step. Don't worry about it. See, I mean, let me give you a very good analogy, right, which will help you resolve this fear. Okay. Have you been to a gym, Ankit?
Yes, sir.
Have you been to a gym? Any
Yeah, yeah.
gym? Very
Yes,
good,
sir.
right? Good point. Okay. Remember the day when you went for the first time. Okay. Uh, you know, I will tell you, right? So in the when I was in school, right? When I would run, I was a very bad guy at physical fitness and so on. So when I would run, I would be the last guy in any race. Okay, let me be very honest. So if there were like 5 people running, I would be the fifth guy. Okay, so in that race. Okay, so so scared of running. Okay. And then then people told me, man, running nahi karega. I also don't do an exercise. Anyway, we are living a sedentary life cycle. Life in the sense sitting in front of a computer. Fitness ke liye, now it is age. I have to do something. Okay. So then people told me, man, if nothing, go to a gym. Get onto a machine and at least start running. Okay. And I started running. Okay. It was like I ran for like, and I couldn't run really, honestly. Okay, first time I ran for like 5 minutes and I was like panting already. Okay, and then gave up, man. I mean, like, kidhar running hone wala hai mere se, right? Not possible. But then the point is, you keep doing it, and honestly, now I can run 10 kilometers happily. Okay, I'm not a marathon runner. I'll be very honest. Okay, I am not a marathon runner, so I can do 10 kilometers. Marathons are 42 kilometers. At some point, hopefully, I can do that. But as of now, I can run 10 kilometers at a stretch on a gym. Okay, on a machine. Okay, and also of course offline on roads as well. But I can do that. Okay, so don't be scared of things. It's good. And I'm sure. So again, many people would be doing all kinds of fancy exercises in a gym, and it pains when you do it. Of course, it pains in the beginning. If there's no pain, there's no gain. Okay, so don't be worried of it. In short, is what I will say. Okay, see, you can do things. I mean, coming from an MBA background, I know, and there are job options for MBA folks where you can do things even without knowing coding. Okay, honestly, but I would tell you that if you know coding, you would end up with better options, Ankit. Okay. So therefore, I think it is a good idea to know some basic Python for sure. Don't worry about hey, it's too difficult. It is difficult. Yeah, for the first timer, it is going to be difficult, but you will catch up. Over time, it will become easier, is the short answer. Okay? Okay?
Okay, sir. Okay,
Good.
thank you.
Okay, so feel enabled. Okay, feel this power inside you that yes, I can do it. Okay, it will take time, but I can do it. That's the idea.
Yeah, yes, sir. Sure. Thank
Good.
you. Thank you.
Great, good, Ankit. So Sumit, Swati, you have questions? I see you unmuted. Okay,
Yeah.
Hello,
go ahead.
I'm
Go ahead,
Swati.
Swati first. Yes, yeah.
Yeah. Sir, I want to know about AI. Means AI is the part of data science or data science is the part of AI?
Very good question. Yes.
Because I am confused about these two things. So
Yeah.
I want to.
Yeah, very good question. Very good question, Swati. So see, Swati, in fact, these days, so data science is a jazzy term which has come up very recently. Okay. So if you look at it, data science as a term was not even present like 10 years back. Okay. So AI used to, but AI is a very age-old term. So in fact, artificial intelligence has been around for like 40, 50 years. Okay. In fact, the neural network algorithms that are part of AI have been around for like 1943 is the oldest algorithm that you can think of, where people discussed about neurons and how to build an artificial neuron which mimics a real neuron and so on. Okay? In short, the answer is AI, data science, big data analytics, those are synonymous terms. If somebody is saying they're doing AI, really they can also be saying that they are doing data science. So short answer, they are synonymous in some senses. Okay.
Okay.
Yeah. Okay. Data science is a marketing term, so to say, okay, or the more in vogue and more in fashion term, but artificial intelligence is more of a technical term. Yeah.
Okay. Thank you.
Great, Swati. Yeah, Sumit, go ahead.
Yeah, actually, sir, I am Sumit Kumar. Actually, I am from New Delhi.
Okay.
Yeah, actually, I have experience 3 years in marketing B2B Reliance Retail Limited.
Okay.
And I left my job in 2019 and 31 December, and I joined in ICI Potential Life Insurance. But sir, actually, I changed in domain in data science. Sir, actually, I have already idea of the Tableau, Power BI, and SQL Server, and Python, and IBM SPSS. Actually, sir, actually, I'm commerce background, sir.
Okay.
Actually, actually 50 company, my CV rejected and commerce background. I am not interested your profile at the company in my mail ID. Yeah, actually, it's my question, sir. Actually, I'm commerce background. Actually, not actually interested company in my profile, sir.
Yeah, very good question. Yeah. I mean, I think this happens with a lot of folks. In fact, I have interviewed people with commerce backgrounds who have done really well in data science. Honestly, okay. A few recommendations, right? When you so basically, you can build up your resume nicely. First step, you can basically say that, hey, remove the background part from your resume. Hey, after you have had good experience, at some point you can basically, ignore the background part from your resume. Okay. If people ask, of course, you can tell them, but you can always say that, hey, by the way, yes, I have, a BCom commerce background, and so be it. But, for the past few years, I'm into data science. Replace that by projects that you have done on data science. I think your experience into insurance and into the retail sector matters more. So put up those kinds of projects. In fact, if you, since you mentioned Python, build some projects, put them on GitHub, put your GitHub profile link into your resume. Okay. That basically tells people what you're capable of doing rather than just they estimating using your background. Okay. So, and also try to participate in Kaggle competitions so that you can put up a Kaggle link there saying, hey, this is my Kaggle profile. I've done this kind of work. See, when people are trying to interview you, they basically want, in a very short period of time, estimate your capability. And if you do not have any other way of showing your capability, the best way is to really look at your educational background. And that is why they pay attention to your commerce background a lot. Okay. Does that make sense?
Okay.
So
Actually,
try to transform your resume to help the HR recruiter or even the other person who is interviewing you. Try to tell them about what you want them to listen. Right?
yes, sir. Actually, today in a research developer in Noida, actually job again 10 o'clock. Actually, I joined a C type company. Actually, today.
Okay, very good.
Yeah,
Very good. Yeah,
research
all the
analyst.
best. All the best.
Research analyst.
Yeah.
Actually, sir, sir, for future in the technical skill and the MCA and MBA in data science, IIT Bangalore. Actually, sir, means मुझे ये करना चाहिए या नहीं करना चाहिए क्योंकि एक्चुअली मेरा जो है सो टेक्निकल कोई स्किल है नहीं.
So you mean the job part?
No, actually
Degree part. Oh, okay. MBA in some. So yeah, I mean,
data
some of
science.
these questions, can be personal. We can take them offline as well. But yeah, see, I mean, in general, doing any kind of education helps. But yeah, one has to weigh कि कितना benefit है versus amount of time and money invested into it. Yeah.
Yeah.
I think
Yes.
these things we can take offline. If you're okay, you can send me email and we can sort of talk about it. Here is my email ID. You can feel free to drop an email to me, and we can discuss such personal things offline.
Okay.
Yeah,
Sure.
look good. So Sai Babu, yeah, placement assistance. As of now, we, I'll let Kalpana also take that one. But as of now, we are not. I mean, see, we believe in basically making people strong enough that they can find jobs by themselves, right? But more of those questions actually Kalpana can also take.
Yes, Manish.
Yes, and so we would like to discuss and answer course-related questions once we're done. Oh, sure. Oh, absolutely. So go ahead. So that's true. I think I am done. I'm sorry if I've taken too long, but hopefully you enjoyed the session. Yes, I should stop now. Oh, sorry, it's already 9:08. So hopefully you like the session.